We're looking at the essential question, what is the difference between elements, compounds, and mixtures? We're going to focus specifically on elements and compounds. Students will be able to differentiate between elements and compounds using a periodic table of elements. Some background information. Dmitry Mendeleev was a Russian chemist and inventor. He formulated the periodic law. He arranged the periodic table by atomic weight and similar properties. He predicted the properties of 8 elements yet to be discovered. Here is a quick video to engage your brain.
He was born in Russia in 1834. Hard work as a youth opened up the college doors. He always tried to be the best that he could be and chose to make his mark in chemistry. And who told the elements where to go? Mendeleev, who put them in columns and in rows. Mendeleev, who was ready, who was able to make a periodic table. Who was that chemist? Mendeleev.
Here is what the first periodic table looked like in March of 1869. That's quite a bit different than what the current periodic table looks like. This is our current periodic table, and everything on here is an element. It is the periodic table of elements. This is an interactive periodic table, and you can see the key is up here. And we've talked about metals and nonmetals and metalloids. So you can see when you hover over that, you can see all of the metalloids. When you hover over the nonmetals, you can see the nonmetals. When you hover over the metals, you can see the metals. When you click on an element, you can see the physical properties of the element right over here. You can also create compounds here. You can see what different compounds, different elements can create. So if I am going to create with hydrogen and oxygen, I can see I can get the different forms of water with my H2O. I could get hydrogen peroxide with 2 hydrogen and 2 oxygen. So these would be compounds. These would be the individual elements that make up those compounds. We're going to review. Matter is everything around you. It's anything that has mass and takes up space. Atoms and molecules are all composed of matter. It can be a solid, a liquid, or a gas. A molecule is 2 or more atoms bonded together, represents the smallest particle in a chemical compound that can take place in a chemical reaction. A molecule has the same chemical properties of that element or compound. Some molecules consist of 2 atoms of the same element, such as O2. Other molecules consist of 2 or more atoms, such as H2O, your water molecule. Pure substance has a definite and constant composition. A pure substance can either be an element or a compound. The composition of a pure substance does not vary. Salt and sugar, their composition does not vary. It does not change. They are compounds and they are pure substances. Hydrogen is an element and it is a pure substance. H2 is 2 hydrogen and it is a pure substance. And H2O is your pure substance of water. Its composition is always H2O. An element is a pure substance that cannot be broken down into any other substance. It's represented on the periodic table by a symbol. AU is gold. We're going to revisit our learning target of being able to differentiate between elements and compounds using a periodic table of elements. We have been focusing on elements, and now we're going to look at compounds. A compound is a pure substance formed when 1 or more elements have chemically combined through a chemical reaction to form a new substance. It is represented by a formula. NaCl is an example of a compound, sodium chloride. You have your sodium and you have your chlorine, and they combine to make sodium chloride, which is table salt. And again, you have your 2 hydrogen and your oxygen to have water. When you count elements in a molecule, you're counting the number of different capital letters or the element symbols in the compound. So you want to look at the capital N and the capital O. And so there are 2 elements in Na2O. You don't count the subscript when you're counting the number of elements in a molecule. You're looking at just the chemical symbol. And so now you should be able to differentiate between the elements and compounds using a periodic table of elements. We're going to model building a molecule using a PhET simulation. I will build a couple for you. We'll then build some together, and then we'll be working independently to build some molecules. After that, we'll come back together and we'll do a review and wrap up, and we'll then assess your knowledge. Let's go ahead and look at this PhET simulation. If you go to the single and click on it, we're going to build a hydrogen and oxygen compound. We're going to build our water. So I'm going to pull my H up here. I'm going to pull my oxygen up here. And then I'm going to pull my other hydrogen up there. And I've created water. And so we're going to add that right there. And now we have our compound of water. When I click this arrow, it will give me some more elements. Remember, these are individual elements. And then we could build our molecular oxygen with 2 oxygen. We can build our molecular hydrogen with 2 hydrogen. And then over here, we can build our carbon dioxide. There's my carbon, oxygen, and oxygen. So 2 elements make up carbon dioxide. And then I have molecular nitrogen, and 1 element makes up molecular nitrogen. And then you click next collection and you keep going. You can do multiple. So I have built 2 carbon dioxide molecules here. Again, when you click the arrow, it prompts you. So I can put 4 hydrogen 2s. So there's 1 H2, there's 2 H2, there's 3 H2s. And start sliding them over here to get them out of my way. And these are all made up of 1 element. They are only made up of hydrogen. So if I'm counting the number of elements, there is only 1 element in 4H2. That 1 element is hydrogen. And then we have our playground where you can explore by building different things. So I have created nitrogen and oxygen. I can unlink those, return them, and I can build chlorine. Let's see what happens if I put H next to that. I now have hydrogen chloride. That's a compound. And so you can explore with that. And then you can separate them back and rebuild. You can get new elements to build different compounds. And you can go back home if you want to move around. So we will now look at doing this together. And then we will look at you guys building some independently and recording those in your journals. At this time, you should be very good at differentiating between elements and compounds using a periodic table of elements. That would be the I do. The we do, like I said, I will have students go back to this PhET simulation and we will be doing it together and discussing it as we go. I'll then give them some time to work on that independently and record their you-dos by themselves in their journals. And then after that, I would come back to the Nearpod presentation and wrap up with a video. And then I would formatively assess to see where they're at. I would formatively assess again. This is more assessment. I would give them a chance to do time to climb, and that would give me some more information to see where they are at in their learning prior to giving them another assessment. If they are not doing very well here, then I would have some interventions to go back to, perhaps make some flashcards, digital flashcards throughout the lesson. I would be formatively assessing. So after talking about elements, I would have something in the Nearpod for them to answer. After talking about compounds, I would have a quiz or a question or a poll for them to answer so that I would know if I needed to add to what I was telling them or if I was going at a good pace for them. And I hope that is what you were looking for. The resources that I would need would be the PhET simulation, obviously Nearpod. I would want students to have a copy of a periodic table so that they could be referencing that as well.